Collis offers me a quote to return to Malthus once more from a different angle. Malthus and other early priests of capitalism constructed a picture whereby unlimited human wants clash with a limited world. Scarcity and growth became an inseparable pair, with limits spurring efforts for growth. My thesis is that it is only when we begin to accept the world as abundant that we can contemplate living our wants and delimiting a safe space for our freedom. Before working towards my closing, I like to highlight one such source of abundance. McGlade and Akins show that the abundance of fossil fuels rather than their pending scarcity gives the most urgent concern. The starting point for their exercise is a global carbon budget of allowable emissions until 2050 to give a coin flip probability of limiting global warming to 2 degrees Celsius. Or in their words, it has been estimated that to have a 50% chance of keeping warming below 2 degrees throughout the 21st century, the cumulative carbon emissions between 2011 and 2050 need to be limited to around 1100 gigatons of carbon dioxide. Next, McGlade and Akins used estimates of global fossil fuels stocks to explore the geographical distribution of what they argue to be the cost-minimizing set of reserves that can be burned to stay within this global carbon budget. Jacob and Hilaire describe the detail in McGlade and Akins their work as follows. In each of the 16 regions modeled, fossil fuels are divided into 21 categories that include various types of coal, oil, and gas. Each category further accounts for key characteristics such as recoverable resources, production and trade cost, as well as natural decline rates of production, the rates of fall that would occur in the absence of any further investment. Their finding may be shocking for anyone that is familiar with fears of peak oil, as the emissions embedded in known resources is about an order of magnitude larger than the earlier mentioned carbon budget. Limiting attention to reserves, that is, the resources that are recoverable under current economic conditions, the emissions embedded in the stocks of fossil fuel reserves are 3 times this carbon budget. According to McGlade and Akins, the results suggest that globally a third of oil reserves, half of gas reserves, and over 80% of the current coal reserves should remain unused from 2010 to 2050 in order to meet the target 2 degrees Celsius. To conclude, these results demonstrate that the stark transformation in our understanding of fossil fuel availability is necessary. Although there have previously been fears over the scarcity of fossil fuels, in a climate-constrained world, this is no longer a relevant concern. Large portions of the reserve base and an even greater proportion of the resource base should not be produced if the temperature rises to remain below 2 degrees Celsius. While the cost-minimizing set of unburnable reserves gives a criterion that seems relatively objective and a useful benchmark, McGlade and Akins, their results table by region, invites a wide range of environmental justice questions. For example, the cost-minimizing set would leave 85% of African coal unburned. Meanwhile, the African continent has only contributed about 5% of cumulative greenhouse gas emissions. The focus of this course will be on inter-species environmental justice rather than our intra-species struggle with inequality. The notion of unburnable reserves is gaining attention, and there is growing literature on how to manage such stranded assets. In this first lecture, I have reviewed how Malthus warned that human population has the tendency to outgrow the carrying capacity of its environment. Subsequently, how contemporary versions of limits to growth and planetary boundaries echo warnings that unlimited economic growth is unsustainable on a finite planet. The Planetary Boundaries Framework proposed thresholds to prevent damage to the global carrying capacity, where this carrying capacity refers to the ability to sustain human activity. Whatever level of carrying capacity implies that we face some absolute scarcity, yet there is no reason for this carrying capacity to be fixed over time. Economic development through education and technological progress can increase global carrying capacity, while imprudent resource consumption can deteriorate it. The end of economic growth does not preclude development. Yet, with the arrival of the Anthropocene, it is becoming increasingly dangerous to ignore that we face absolute scarcity. Accordingly, I have focused on this idea of spaceman economy and its underlying concept of absolute scarcity. The alternative notion of relative scarcity, characteristic for the cowboy economy, appeared only briefly through the discussion of Solow's work. Arguably, one could also describe this cowboy economy, where it is best to grow as fast as one can, as the caterpillar stage of the economy. However, unlike our capitalistic economies, caterpillars seem to know instinctively when it is time to stop growing and pupate. Much of the biodiversity conservation literature calls for a similar transformative change of the economic system. In the later lectures, I explore how policy could help our economies to pupate, and I invite you to imagine what a butterfly economy might look like. In this lecture, I focused much on scarcity and limits. Yet, as a gardener, I tend to agree with Collis in that the limit resides in the subject and the attention, not in nature, which is indifferent to our intentions. And it is our intentions that should be limited. Paradoxically, to escape absolute scarcity, seeing the world as abundant may be most fruitful to explore limits. Growth is no longer an objective in the butterfly stage of the economy. Instead, one can only hope that vision and purpose lead economic activity to planetary well-being in the face of challenges with both abundance and scarcity. Balding's reference to Mercator's projection also gave me an excuse to show one of my favorite maps. Balding refers to the projection as having hindered to perceive Earth as a spaceship. Another unfortunate byproduct of Mercator's projection is the distortion of accurate sizes of different countries. The map shown here by Neil R.K. displays the corresponding land size in bright colors alongside the familiar Mercator projection, showing that area further away from the equator looks bigger on Mercator's map than it is in reality. In the next lecture, I give more attention to environmental economics, or neoclassical economics, the school of economic thought that focuses mainly on relative scarcity, by discussing the marginal revolution, market failures, and the tragedy of the commons. Given the abundance of fossil fuel reserves, one could wonder to what extent models of demand and supply are still informative on how to manage climate change. Still, I argue that these simple models may help to understand the source of various environmental problems and solutions offered to aid biodiversity. Here you can find some of the references that I've used for this lecture, and the references continue on this slide. You may want to pause if you want to inspect them closer. Another slide with references in full, and the last slide with references. Thank you for your attention. In case you like any of the videos, feel welcome to share or subscribe. Hope to see you back for the next lecture.